Tens of thousands of years ago, our ancestors spread across the world, having sex with Neanderthals, Denisovans, and other groups of ancient humans as they went. Today, our genes testify to these prehistoric liaisons. In 2010, when the Neanderthal genome was finally sequenced, it emerged that everyone outside of Africa can trace 1 and 4% of their DNA from Neanderthals. Some people saw the discovery as vindication, while others were taken back. Paleontologists have been at odds over various theories regarding the origins of early humans for many years. Some favored the out-of-Africa theory, according to which every early human group was replaced by a tiny group of ancestors who swept the globe after leaving Africa. In its most severe forms, this theory claimed that these societies never engaged in sexual activity, or at least never successfully reproduced. The alternative, the multi-regional model, sees these ancient peoples as being a part of a single population that interacted and interbred often. To an extent, these are caricatured versions of the two models, and there are subtler variants of each. Still, early evidence seemed to support the extreme out-of-Africa version. When scientists sequenced the mitochondrial genome of Neanderthals, a small secondary set of genes set apart from the main pack, they found no evidence that any of these sequences had invaded the modern human genome. The conclusion: Neanderthals and humans never bred. The whole Neanderthal DNA refuted that theory, but it also raised the question of how much sex the two species shared. Neanderthals were moving into locations where modern humans were developing. Genes from a native population can invade the colonizers' genomes with relatively little sex. The genes they acquire from mating with an established group quickly become more prevalent as their number increases. Now, Matthias Kurat from the University of Geneva and Laurent Escoffier from the University of Bern have weighed into the debate. To determine the levels of intercourse that would have introduced Neanderthal genes to contemporary genomes at their current level, they replicated the expansion of modern humans from Africa and their interactions with Neanderthals throughout Europe and Asia. The pair concluded that having sex between the two groups was a bit of a novelty. A fertile, healthy hybrid offspring was born from less than 2% of the conceivable sexual interactions between humans and Neanderthals at the time. The true probability might have been substantially lower. That estimate is merely a conservative one. According to Escoffier, such interbreeding were fiercely discouraged or very rarely successful. Even if the odds of successful interbreeding were just 5%, Neanderthal genes would make up the majority of the human genome today. As it is, a lack of viable sex explains why none of the Neanderthals' mitochondrial DNA made its way into modern humans, and why so little of their main genome did. According to Kurat and Escoffier, modern humans and Neanderthals either didn't have sex very frequently, or their hybrids weren't particularly physically fit. They prefer the original suggestion. Their model predicts that it would have only taken 197 to 430 contacts between Neanderthals and early humans for 1 to 3% of present Eurasian genomes to include Neanderthal DNA. It would have been sufficient for one human to sleep with one Neanderthal every 23 to 50 years, given that the two populations likely interacted for about 10,000 years. David Reek, one of the leaders of the Neanderthal sequencing effort, is not surprised. People today mix with people who speak their language and share similar traditions, and these groups were more diverse than modern ones, he says. This says to me that where modern humans and Neanderthals were in the same area of the world, Neanderthals would tend to mix with Neanderthals and humans would tend to mix with humans. I would be shocked if they mixed randomly. In the first waves, small groups of modern humans would have met large groups of Neanderthals. In later waves, the situation was reversed. The encounters between the two groups would have been very different across many thousands of years. Stringer asks, the remaining question is whether those earliest modern waves survived to contribute their genes, including Neanderthal ones, to the succeeding waves, or was the slate essentially wiped clean each time? What do you think of our video? Let us know in the comments below. If you enjoyed this video and would like to hear more from us, please subscribe to our channel and turn on notifications before you go. Thanks for watching.